Okay, let's dive right into this explainer and demystify something that sounds, well, completely absurd at first glance. The astronomical price tags attached to industrial off-the-road tires. If you've ever had to replace a set of tires on your car, you know the drill, you know the rough cost, but the economics of heavy machinery, they operate on an entirely different planet.
So, let's kick things off with a massive, almost unbelievable question. Why on earth would a fleet manager or a mining company willingly pay up to $80,000 for just one single tire? I mean, it literally sounds like a typo, doesn't it?
$80,000. That staggering number creates some serious, immediate sticker shock for anyone used to buying regular consumer car parts. You could literally buy a luxury sports car for that. But as we're about to uncover here, every single dollar of that price tag is backed up by extreme engineering and undeniable physical necessity. It is absolutely justified.
There is just a sheer, uncompromising contrast between the lightweight tire on your commuter car and this industrial giant. Specifically, a 5980 R63 off-the-road tire. Just think about the numbers for a second. Your standard car tire weighs maybe 8 to 10 kilograms, holds about 1.5 kilograms of light steel wire, and sets you back around $100. But this OTR giant, it tips the scales at over 5,200 kilograms. It contains roughly 1,000 kilograms of high-tensile steel cord alone and operates at well over 100 psi. The sheer scale is just mind-blowing.
To really wrap your head around that insane scale, imagine standing next to a tire that is 4 meters or about 13 feet high. That is literally the size of a one-story building. You'd barely reach the lower rim. This isn't just a vehicle part. It's practically a massive architectural structure made of rubber and steel. So let's break down exactly why they cost so much, starting with reason 1, extreme scale and raw materials. We're talking about a tire used on massive mining dump trucks that weighs in at an earth-shattering 5 metric tons. That is heavier than 3 standard passenger sedans stacked on top of each other, all concentrated into one single wheel. And that colossal weight isn't just, empty bulk. It's packed with an incredible volume of premium-grade natural rubber, high-tensile nylon fabric, and up to 1,000 kilograms of heavy steel cords. All these materials have to be perfectly integrated and woven together with absolute precision to maintain structural integrity. Right out of the gate, you're paying for a massive quantity of highly refined raw resources. Moving right along to reason 2, the semi-manual manufacturing and extended curing process. See, while the tires on your daily driver are basically churned out rapidly by robots on fully automated assembly lines, these industrial behemoths require something much more artisanal, believe it or not. They go through a really meticulous, semi-manual building process. Layers of steel bead, plies, and the thick tread are actually assembled layer by human hands with the help of high-precision machinery. It is practically bespoke tailoring just for a multi-ton dump truck. And this process demands a massive time investment, 12 to 24 hours. That's how long it takes to vulcanize these incredibly thick rubber layers inside massive molds. They're subjected to extreme heat and pressure for up to a full day, just to ensure absolutely no air pockets remain trapped inside. It's kind of like baking a massive, highly dangerous cake. If even a tiny air bubble is left in that thick rubber, the whole tire could fail catastrophically under load. Which brings us to reason 3, specialized rubber compound formulations. Fleet managers actually have to select bespoke chemical blends based strictly on their working environment. Operating in a harsh quarry, you're going to need cut-resistant compounds, formulated with incredibly dense polymers to stop sharp rocks from slicing right through the tread. On the flip side, if you're doing long-haul, higher-speed runs, you need heat-resistant compounds designed to rapidly dissipate heat. Without these highly specific chemical additives, you'd get internal tread separation or blowouts almost immediately just from the heat buildup. And that leads us to reason 4, safety engineering for extreme load capacities. Think about this. These tires are the absolute sole point of contact between the ground and these multi-ton machines. Picture a rigid dump truck carrying a full payload of ore. That vehicle can weigh up to 400 tons. All of that incredible weight, all that momentum, rests entirely on these patches of rubber and steel. Because of that extreme pressure, we have this incredible quote from the source material: "These tires are built to aerospace-grade safety margins." And why is that? Because a blowout under 400 tons of weight wouldn't just be a minor headache. It would lead to devastating accidents, potential loss of life, and millions of dollars in operational downtime. The cost of failure is so unbelievably steep that the manufacturing tolerances essentially have to rival those of a commercial airplane. Now let's get into the real paradigm shift here: cost per hour. In the mining and construction world, buyers completely ignore that initial $80,000 sticker shock. Seriously, they look right past it. Instead, they strictly evaluate their investments using this one specific calculation, cost per hour, or a CPH. It's determined simply by dividing the initial purchase price by the total operating hours the tire survives out in the field.
By tracking exactly how long a tire actually survives in the dirt before failing, fleet managers can completely cut through the noise and determine the true return on their investment. It is a brilliant way to quantify durability. At the end of the day, it's all about exactly how much work you get out of the asset.
Running the numbers here reveals the ultimate secret of industrial economics. Let's say we're looking at a slightly smaller but still premium OTR tire costing $40,000. If it lasts 6,000 hours of operation without structural failure, it only costs $6.67 per hour to run. But a quote-unquote cheap, low-grade alternative priced at half as much, just $20,000, might fail catastrophically after just 1,000 hours. Suddenly, that budget tire is costing you an agonizing $20 per hour. And remember, that doesn't even factor in the massive financial hits from machine downtime and hazard repairs.
So, the absolutely crucial point to take away from this is, the $40,000 premium tire is actually 3 times cheaper to operate than the $20,000 budget alternative. By spending vastly more money up front on extreme engineering and premium materials, the fleet owner is actually buying the absolute most economical and efficient option available.
It completely changes how you look at a price tag, doesn't it? Now that you understand the hidden ROI and extreme engineering behind an $80,000 tire, it leaves you with a pretty fascinating question to ponder. What other astronomical industrial costs out there are actually hiding brilliant economies of scale, saving companies millions in the long run? Thanks for joining this explainer, and keep looking for the real value hiding behind the numbers.